In our next section, we're going to look at how Ethernet interfaces and Ethernet switching work in JunoOS. And first off, we're going to talk about how interface units work in JunoOS, similar to how subinterfaces work in iOS. We'll talk about the address families at the link level and specifically what they're used for. I'll talk about how we configure both layer 2 switch ports and layer 3 routed ports in JunoOS, the difference between access and trunk port configuration, the VLANs, spanning tree, and then finally Ethernet link aggregation. Now, as we saw in a couple of the examples up to this point as we were exploring the basic CLI, for example, setting an IP address, we saw that one of the properties under the link level was what we had as a unit. Now, a unit in JunoOS is essentially the same as a subinterface in iOS, where in regular iOS, when we configure an address on an interface that doesn't have a subinterface number, that's considered to be the main interface, where in JunoOS, the equivalent of this is unit 0. Now, every interface requires unit 0, and the end result of this is that it separates the logical properties of the interface from the physical properties of the interface. For example, for Ethernet, a physical property would be something like the speed in the duplex, where a logical property would be something like the IPv4 or IPv6 address. Now, certain encapsulations likewise can have more than one unit, just like they do in iOS. So if we have Ethernet, we can have multiple 802.1q subinterfaces, or specifically .1q units. In Frame Relay, we could have multiple data link connection identifiers. In ATM, we could have multiple permanent virtual circuits, and then those would individually be assigned to different units. Now, when we're dealing with units and Ethernet interfaces, the unit is going to be talking about a specific VLAN, but just like in iOS, the number of the unit doesn't directly relate to the VLAN number. So for example, you could have unit number 10 that is encapsulating VLAN number 20. It's simply a locally significant value that you're binding to the interface. But in the vast majority of real designs, just like you would in regular iOS, it doesn't make sense to mismatch the numbers because it makes the configuration overly complicated to read. So when you do the configuration, typically you would match the VLAN ID to the unit number, but it's not 100% required. So here in this example, this is basically the equivalent of doing a router on a stick type configuration in iOS, where we have the main interface, which in this case is GigE000. We're saying to do VLAN tagging. Basically what this is doing is turning on 802.1q. So now the interface is listening for tagged packets, and it says I have a subunit number 12, which is basically a subinterface, where this would then be denoted as GigE-000.12. And on that subinterface, or unit.12, we have VLAN ID 12, and then we have our other logical configs. In this case, we have an IPv4 address, and we have an IPv6 address. Now, under the unit then, we also have the address family, which is essentially enforcing the hierarchy a little bit further in JunoOS versus what we have in a regular iOS. So if we were to look at an iOS config where we have both IPv4 and IPv6, different routing protocols like OSPF and ISIS at the same time on multiple interfaces, a lot of that config gets grouped together either at the interface level or all under the global routing process. So unless you know exactly how to sort through what config belongs to what protocol, it makes it a little bit overly confusing, especially when the config starts to get very large. Now, in the case of JunoOS, there's explicit separation of which properties belong to which protocols by putting them under different hierarchies in the stanzas when we look at the output. And essentially, this is what the AFI, the address family identifier, or simply the family from a configuration point of view does, is to say that if we're doing Ethernet switching, those options should be under family Ethernet switching at the link level. Or likewise, if we're doing IPv4 routing, those options should be under family INET at the interface level. So then when we look at the running config, or simply the active config, we can see what particular options are talking about MPLS label switching versus regular native IP routing. Or in the case of ISO, this is if we're doing IS to IS routing, we would need to enable the ISO NSAP address, which is the network entity title, essentially the router ID for the ISIS process. Now, from a hierarchy point of view, The family goes under the unit because different units, different subinterfaces can have different IP addresses. So we could have an INET address on a unit 0 while we have an INET 6 address on unit 1. It just depends on how we manually bind the unit to the particular layer 2 address underneath. Where in the case of Ethernet, the layer 2 address is going to be based on the VLAN number plus the MAC address. Other encapsulations like Frame Relay would use the DELC, ATM would use the VPI VCI, but it's the same type of principle that from a layer 2 forwarding point of view, we're separating it into multiple logical circuits on the same physical interface. Now, from a configuration point of view, in iOS versus Junos, when we're doing multiple subinterfaces, we're doing the same end result, that we're using a single physical interface to do routing between multiple layer 2 segments, and we're doing that by creating the multiple units. So in the case of iOS, we say encapsulation.1q10. This is the combination of both the VLAN tagging command under the global interface and then also the VLAN ID under the unit number, where again, normally the unit number is going to map to the VLAN ID, but technically there's separate variables. Then we have the IP address, which is going to be under the unit, under the family. In this case, the family is IPv4, and then we have the particular address that's assigned. Okay, so let's take a look at this on the CLI, and let's take a look at our physical diagram that we're going to be using, where let's say that we want to get basic connectivity between some of the SRX routers. We're going to start with SRX1, and we're going to try to get connectivity to some of the other iOS devices. So we have XR1 up here, which is running iOS XR, and then we have our other regular iOS devices, the 7200 VXR, the cloud services routers, and then we have the Catalyst switches, the ME3400, and the Catalyst 3560. So ultimately, in terms of Ethernet, we're trying to establish just basic layer 2 connectivity. So from the end device's point of view, the routers in this case, they're going to be running IP. The switches in the middle are going to be doing regular layer 2 Ethernet switches, Ethernet switching on both access ports and on trunk ports. So from the end device point of view, let's say from SRX1, let's say that we want to create two different VLAN subinterfaces, that we're going to have VLAN 10 and we're going to have VLAN 20. And we're going to configure this on a single link that's going up to our Ethernet switch, which is EX1. And then ultimately, we want to break this out so we can trunk VLANs 10 and 20 to the other switches, and then get IP connectivity to the remote devices. Now, from the iOS configuration point of view, if we look at, for example, CSR1, let's say that we're going to do our VLAN subconfiguration on this box, we need to make sure that we have our main interface up. So if we look at the show IP interface brief, in the case of iOS, we can see the link is up and up. Again, the equivalent of this in JunoOS, and actually let's look at these side by side here. So we have iOS on the top and JunoOS on the bottom. This is going to be the equivalent of the show interfaces terse. Okay, so first thing we want to make sure that the link is actually in the up state. So we can see admin up, link is up. That's the same as the status in the protocol here in regular iOS. So we can see that we have the main interface, in this case gig E000. In the case of iOS, this is gig 1. For iOS, we would go to our Ethernet subinterface, gig 1.10, encapsulation.1q10, that's binding the VLAN number to the subinterface, and then we apply our logical options like the IP address. So let's say 10.0.0.1. In the case of the JunoOS box, we would go to configuration mode. We're going to edit our interfaces, gig E000. That's going to bring us into the hierarchy under interface and the interface name. We're going to edit the unit. We're edit unit 0. We're going to edit the address family, or actually the family, INET. And we're going to, actually no, we're going to create a new unit. We're going to edit unit, let's say 10. Edit the family, inet and set the address. Address will be 10.0.0.2/24. Now, in the case of JunoOS, if we look at the show pipe compare, again, that's going to show what are the uncommitted changes. And let's say top show pipe compare that says, show me from the root hierarchy everything that has changed in the new candidate config. We've created under the interface, we've created the new unit, so unit number 10, and we're giving it an address. Now, if we go to save these changes, there should be a couple things that the OS is going to complain about. One of them is that we haven't set the interface yet to do .1q encapsulation. That's going to be to turn VLAN tagging on globally under the interface. Okay, because it says right now only unit 0 is valid, because if we're not doing VLAN tagging, then the router is not going to be able to tell one packet versus another when it's trying to land on different units. So not only do we need to enable tagging, but we're going to need to set what particular VLAN number it is. So the point being here is that in the case of iOS, we're doing the same thing, it's just that the syntax structure is different. So defining the unit or the subinterface is technically a separate step than turning the encapsulation on and then specifying what the encapsulation number specifically should be. Where in the case of JunoOS, this would be under the interface. We're going to say that under unit 10, we're going to set the VLAN ID to 10. And then under the main interface, we're going to set VLAN tagging. If we then say top show pipe config, or no, show pipe compare, now unit number 10 is going to be encapsulating VLAN 10. Now this should, I believe, still give us an error message here when we go to commit. And the reason why is that unit 0 doesn't have an explicit VLAN ID configured. So it's essentially saying that even though unit 0 is what in the case of iOS would be the main interface, JunoOS doesn't do native VLAN untagging by default. And we'll talk about that in a little bit more detail here shortly when we look at Ethernet trunks. But in the case of iOS, your main interface is normally for your untagged Ethernet packets. But in the case of JunoOS, there's no untagging by default. Everything is tagged regardless of whether it's the native VLAN or not. So in this case, it's saying a packet comes in and we don't know how to associate it with unit 0 because there's no VLAN 0 inside of the actual header. So either I would need to go and define a VLAN number for that particular unit, or simply remove the unit. So if we delete unit 0, then top show pipe compare and commit, then this should be valid. Now we haven't yet set up the layer 2 switches, so we're not actually going to be able to get connectivity end to end between these devices. But once we configure trunking all the way between the switches, then we should be able to ping between CSR1 and SRX1. Okay, from operational mode now, let's say exit config. And if we look at the show route, we should see that this is a directly connected interface. Okay, we need to make sure that this is an active route, so it should have the star here that it's being used. Now, in terms of Ethernet switching, JunoOS supports, just like Catalyst iOS does, it supports routed ports and it supports layer 2 switching. But it doesn't support both at the same time. It's going to be one or the other. So when we think of the iOS command switch port, that's the equivalent of the family Ethernet switching in the case of JunoOS. So if we have both family Ethernet switching and VLAN tagging, it's not going to allow it. Those are mutually exclusive. And where we would see that error is when you go to commit the config, then it checks to see whether it's actually a valid setup or not. So if the port is configured with the family Ethernet switching, this is the equivalent of saying it's going to be a layer 2 interface. It's going to be a layer 2 switch port. So in the case of the switches, if we look at the EX switches, and let's say show config, under the interfaces, these are going to be family Ethernet switching by default. Essentially what this means is that these are going to be access ports that don't have any VLAN tagging applied. So it's the same as like a default Catalyst configuration that everything is in VLAN 1. Same thing is true here with the EX switches in Juno S. So assuming that you just plug devices into the switches, you technically don't need to configure it. It should be able to switch between that local VLAN without any additional configuration. Now, in terms of configuring routed ports, in the case of iOS, we would do that by issuing the no switch port command. In the case of Juno S, we would simply do that by deleting the family Ethernet switching, and then we could replace it with the family iNet or the family iNet 6 if we're doing IPv6 routing. In either case, we can look at the show interfaces, and then if we look at the detail there, under the protocol field in the case of Juno S, that's going to tell us what are the particular address families we're running. Or if we simply say show interfaces terse, that will tell us is the port a layer 2 port or is it a layer 3 port. So for example, here on the switch, if we were to say show interfaces terse, when we look at the families, if the family is ETH switch, it means it's layer 2. Now again, we can change these to layer 3, like if we were to say show config interface GigE001. We can see right now this is a layer 2 port. If we were to go to config mode, to edit interface GigE001 unit 0, we would then delete family Ethernet switching, and we would set family iNet, and specifically set an IP address. It says when family Ethernet switching is configured on an interface, no other type can be configured. Let's say show pipe compare. And actually, top show pipe compare. I think there's some old config from before, which was that config there. So actually, let me delete those. Let's say rollback 0. Okay, that's deleting. I need to go to top. Top, then rollback 0. That's aborting the config. Then I'm going to do what I did before, which is to edit that interface, delete family Ethernet switching, and then set the IP address. So again, the point being is that if you have uncommitted changes and you exit from config mode to operational mode, they don't get deleted. They stay in there until you go back to config and either clear them out or actually save them by committing them. So let's say commit and quit. And then once this applies, we're going to show interfaces terse. So in this case, we can see now this port is a layer 3 port because it has family iNet assigned as opposed to the other layer 2 interfaces that have Ethernet switching assigned. Okay, and the other one, which was the show interfaces and match protocol, that would show the detailed output. So if we show interface GigE000 and just look at the full output, towards the bottom there's a section that says what are the protocols. This says what are the address family identifiers, what are the families. So in this case, it's saying it's running layer 2 Ethernet switching, and the port is running as a trunk. If we look at the same output here for GigE001, it should say the protocol is iNet, which means that it's running IP routing. Now, additionally, right now there's only one address configured, but it also has this flag that is preferred. We'll talk about this a little bit later when we look at the details of IP routing in Juno S, but since you can have multiple addresses on an interface at the same time, you need to tell it what address do you want to use as the primary one. So otherwise, it's based on the specific number, the higher number or the lower number. If there's one value that you want to configure as primary and the other ones are as secondary, like in iOS, you do that by setting this flag, which is the is preferred. Now, in terms of the layer 2 interfaces, when they are doing Ethernet switching, just like in iOS, the switch ports can be either access ports or they can be trunk ports. Now, the default port mode in Juno S is none, which essentially means that it is an access port. So when we looked at the config on the EX switches, the only thing that was under the interface level was Unit 0 and family Ethernet switching, which essentially means it's an access port in VLAN 1 by default. Now, if we did want to configure it as a trunk port, we would go under the Ethernet switching family and then set the flag that is port mode trunk. And this is the equivalent of iOS's switch port mode trunk. When we look at show Ethernet switching interfaces, we'll see this is the equivalent of the show interface trunk in the case of iOS. So this is going to tell us a number of different things that we would need to know if we show Ethernet switching interfaces. It's going to tell us, is the link an access port? Is it a trunk port? If it's an access port, what is the particular VLAN? If it is a trunk port, what VLANs is it actually trunking? And what is the status of spanning tree? So here this would tell us, is the tag being configured? So is .1Q tagging on? What particular VLANs are being tagged? And is spanning tree forwarding it, or is spanning tree blocking it? Now we'll look at the details here of spanning tree a little bit later, but by default, most of these switches are going to be running rapid spanning tree protocol, but they're going to be running only a single instance of it. Where when we look at the Catalyst iOS, it's normally running rapid spanning tree on a per VLAN basis. It's running rapid PVST. And we'll see that those two are not interoperable, because to run one instance of spanning tree per VLAN is a proprietary implementation on the Cisco side. So we can get them to interoperate, but it requires configuration on both sides in order to make sure that the spanning tree instances match up. And this would be one of the indications whether that is working or not, which is going to be, again, here, show Ethernet switching interfaces. Okay, so let's say here for simplicity then, we're going to configure all of these interfaces on the EX switches as trunk ports. So specifically, it's going to be this port here that goes from us to the iOS side, these two ports here that go from us to the iOS side, and then the two links between them, and then essentially all of the other ports that go down to the other routers. So to do this again, if we look at EX1, let's look at the show config. And we're going to look at show config on the interfaces. So right now we have on Gig E0, we're running Ethernet switching. So this is a layer 2 port. The port mode is set to be trunk, and the VLAN members are all. Okay, now this one is important here because the trunk ports by default, in the case of JunoS, do not allow any VLANs, which is the equivalent in iOS of saying switch port trunk allowed VLAN none, which is kind of confusing if you didn't know that this was the default option. You configure the link as a trunk. It's not going to pass any traffic unless you manually define the VLANs on the particular interface. And the way that we do this is by saying under the Ethernet switching address family, what are the VLAN members? And the verification is the same as the command that I just showed, which is show Ethernet switching interfaces. So right now, when we look at that output and we look at the show Ethernet switching interfaces, if there's no VLANs listed here, then it means it's not actually doing any forwarding. Okay, we can see all of these other ones are in the default VLANs. So let me roll back my changes here so we can get back to what the default config was. So let's go to config and let's say show pipe compare rollback 2. And I want to get this back to the point where basically, I believe it should be, this one, rollback 5. Okay, rollback 4 is going to get me back to my default config. Let's roll back 4. And then we will commit and quit. And once that's done, let's show config. Okay, while we're waiting for that, let's take a look at the other switch and we'll do the same thing. Let's say exit config, and show config. And specifically, I'm looking at the interfaces. So you can see by default, basically the only thing they're doing is their access ports. So we're going to configure these as trunk ports. Now, before we do this, though, just like in Catalyst, we need to create the VLANs. Because even if we're doing trunking, unless there is a MAC address table that is associated for that particular broadcast domain, the switch is not going to be able to do any forwarding. Now, the JunoS switches do not support VLAN trunking protocol, or VTP, so basically we need to manually define the VLANs. There are some other ways to automate this, but at least for the simplest implementation, we're going to just make sure that we configure the VLANs everywhere. So like in the case of iOS, we would go to global config and simply say VLAN 10, VLAN 20. Same thing is true in JunoOS, but it's going to go under the VLAN subconfiguration mode. So we would edit VLANs, set the VLAN name, and then give it the VLAN ID. Then verification is actually the same between JunoOS as it is in iOS. We would just say show VLAN Brave. So in our particular case, we're going to create two different VLANs, 10 and 20. We're going to say in config mode, config, set VLANs, or actually let's go to edit VLANs. We're going to set, we give it a name, we'll say VLAN 10, has a VLAN ID of 10, and VLAN 20 likewise has a VLAN ID of 20. Now these names are case sensitive, and there's not any error checking in the syntax parser that if I type in lowercase VLAN 10 here and then later reference uppercase VLAN 10, it's not going to give you an error. So in general, either all of your user-defined values, you would either put them all in lowercase or all in uppercase to make sure that you always have the same naming convention. So you want to try to stay away from saying things like set VLAN 20, for example, capital V, because then it gets a little bit too difficult to remember what was the specific variables that you're trying to look for, even though, like we talked about, JunoOS does do completion for variable names. So you could say capital V and then tab, and it would do the auto-completion of what the name is. In the case of iOS, it doesn't do auto-completion for variable names, at least in regular iOS. Okay, so if we show pipe compare, this is what's creating our VLAN. So let's commit that change. We'll do the same thing on the other switch. So let's say config. We're going to set VLANs, VLAN 10, VLAN ID 10. Set VLANs, VLAN 10, VLAN 20, VLAN ID 20. Then in the case of Catalyst, we would just say that in a global config. So we would say VLAN 10, 20. Okay, same thing on the ME switch. Config T, VLAN 10, 20. Okay, so this is just creating the MAC address table for those particular VLAN instances. Now, we're not yet forwarding them because we didn't configure trunking, and we don't have any access ports that are actually in those VLANs. So it's still another step beyond this. We need to make sure that we have the either the VLAN configured as an access port, or we're going to configure a trunk port that is including that particular VLAN number. Now, on the case of the Catalyst side, we're going to be configuring trunking on this port here and these two ports. So let's say on the ME3400, that's going to be on port Fast Ethernet 023. If we show run interface F023, this is a network-to-network interface, and it's a trunk port. If we look at the CAT3560 and show run interface F02 and show run interface F03, those are both .1Q trunks. So let's say on those ports, 2 to 3, no shutdown.